Example 3. Designing a front door for a home using StatCrunch. When designing equipment, one common criterion is to use a design that accommodates at least 95% of the population. What is the height of a door that would allow 95% of adults to walk through the doorway without bending or hitting their heads? Based on data set 1, body data in Appendix B, assume that heights of adults are normally distributed with a mean of 66.2 inches and a standard deviation of 3.8 inches. And then, how does the result compare to the door height of 80 inches required by the International Residential Code? So the first thing we're going to do is we want to draw our bell curve. So let's draw our bell curve. Okay, and then we're going to locate and label where the mean is. So we know that the mean is going to equal 66.2. Okay, and we also know that the value of x, I'm just moving this over here a little bit, the value of x over here on this scale represents inches. Okay, which is the height. So what we want to do is we now need to represent at least 95%. Well, at least 95% is going to shade everything to the left, which means 95% of this bell curve is going to be shaded. So that means that we're going to shade everything to the left of this bell curve. So now that we've shaded that, we can now label that's the area. So the area, which is 95%, can also be written as 0.9500. And so what we want to determine is, what is this x value here? This is the question that we want to find. Now also recall that we also need to include the z-scale, because we need to determine what is that z-score. So we know that for the z-scale, we know the mean is going to be 0. And we want to be able to find out what is the z-score according to the area of 0.9500. So we have drawn the normal curve, and we shaded the desired area to be 0.9500. And remember, at least means the area to the left of 0.9500. So the shaded area represents the shortest 95% of adults. Now the drawing shows the normal distribution with the height x that we want to identify. Now when using the following formula, x, which is equal to the mean plus z times the standard deviation, what we wanted to determine first is the z-score, so we can plug it into this equation and then solve for x. And so using StatCrunch, we're going to click Stat, select Calculators from the drop-down menu, and Normal from the sub-menu. We want to make sure in the calculator box that the mean is 0 and the standard deviation is 1. And since we are looking for the z-score, we're going to locate the bottom right box after the equal sign. And then we're going to enter the area of 0.9500 for the area. And then we are looking for the z-score with the area to the left of that. So we're going to make sure that we select the less than or equal to and then select Compute. So opening up StatCrunch, we're going to select Stat, Calculators, and then go to Normal. We know that our mean is 0, our standard deviation is 1, and so we want to make sure our inequality is less than or equal to, and now we're going to put in the area of 0.9500. And let's see if it matches our drawing that we end up drawing ourselves. So it does. So let's go ahead and then copy this just to make sure that we know that it matches that graph. And so what our goal is first here is to find out what that z-score is. Well, if you notice, there is the z-score. Okay. And we know that that z-score represents 1.645. So now we found that z-score of 1.645. Now we have all the information that we need to find the value of x. So with the z-score of 1.645, the mean of 66.2 inches, and a standard deviation of 3.8 inches, the result of x can be found directly by using the following version of the conversion formula. So we're going to take x, which is equal to the mean, plus z times the standard deviation. So we have 66.2 plus 1.645 times 3.8. So do what's inside the parentheses first and then add 66.2, and we get 72.451. Now we're going to round that to one decimal place, which gives us 72.5. So now we found that x is going to be 72.5. So the solution of x equals 72.5 inches is reasonable because it is greater than the mean of 66.2 inches. And so here's the interpretation. A door height of 72.5 inches would allow 95% of adults to walk through without bending or hitting their heads. The door height of 72.5 inches is well below the height of 80 inches required by the International Residential Code, so more than 95% of adults could walk through the doors meeting this requirement without bending or hitting their heads.